Hi everyone, Assalamualaikum warahmatullahi wabarakatuh and good day. Okay, so in this video, we are at the very last part of chapter 3, which is application in RLC circuit for system of first order linear differential equation. Okay, so if you still remember in the previous video, we had learned on the step-by-step on how to solve the homogeneous system and non-homogeneous system. Okay, so now in this video, we are going to see how to apply those methods in the application in RLC circuit. Okay, so let's have a look at the following example. Okay, kita pergi kepada contoh yang pertama. Okay, katalah you diberi network sebegini, di mana you ada combination of series and parallel circuit. Okay, so soalan dia, refer to the given circuit network, show that a model for current I1t and I2t is given by this equation. And then next, find the general solution for I1t and I2t. Okay, so macam biasa, solution dia, usually bila kita diberi circuit, you lukis balik circuit tersebut, and then based on the question, dia diberi direction for loop current I1 and I2 adalah pusingan jam sebegini. Okay, so once you ada I1 and I2, kita boleh kita boleh marking the polarity for each of the elements. Okay, so untuk passive element seperti inductor, resistor, so the current flow from positive terminal to negative terminal. So that's why you ada positive VR1, positive VR2 and positive VR1. Okay. So untuk active element, current flow daripada terminal negative to terminal positive. So that's why you ada negative, positive, E. Okay. So once you dah tulis polarity for each of the elements, kita boleh apply KVL. Okay. So KVL for the left loop equal to, according to KVL, total of voltage drop is equal to total of voltage rise. Okay. So voltage drop dia VL1 plus VR2 plus VR1, okay, equal to voltage rise, which is E. Okay, so and then after that kita boleh substitute each of the elements, each of the term with the formula. Okay, so for VL equal to L di over dt. So in this case, L is 1 Henry and then I dia adalah I1, so that's why you ada di1 over dt. Okay, untuk VR2 sama juga dengan R2, which is 4 ohm, multiply dengan current. So current adalah I1 minus I2. Okay, so 4 multiply dengan I1 tolak I2, tambahkan dengan VR1. VR1 adalah R1 adalah 2 ohm, 2 multiply dengan I dia adalah I1. So that's why you ada 2 I1 equal to E equal to 12 volt. Okay, so once you substitute everything, you can rearrange it so that you have I1 prime is equal to negative 6I1 plus 4I2 plus 12. Okay, so this considered as a equation 1. Okay, so next we go to the second loop. So untuk second loop ni juga, kita marking polarity for each of the elements. So untuk inductor ni, current mengalir daripada positif ke negatif. So that's why you ada positive, negative VL2. Here you ada positive, negative VR3. Okay, and then KVL for the right loop is given by VL2 plus VR3 is equal to VR2. Okay, and then after that, you just need to substitute each of the term with the formula given. So VL equal to L di over dt. So L is 2 Henry, I is I2. So that's why you ada 2 di2 over dt plus VR3. VR3 is 4 ohm multiply dengan I2 equal to VR2. So here VR2 you have 4I1 minus I2, so that's why here you just use the same value. Okay, 4 multiply I1 minus I2, and then after that you just rearrange the equation so that you have I2 prime equal to 2I1 minus 4I2. Okay, so this is considered as a equation 2. So here, based on equation 1 and based on equation 2, we can write down the equation. Okay, in term of the matrix I prime equal to matrix A multiply with matrix I plus matrix G. Okay, so how to form the non-homogeneous system? So this is matrix I prime, which is I1 prime, I2 prime equal to matrix A. Matrix A is negative 6, 4, 2 and negative 4. Okay, so this is matrix I, and this is the matrix G. Matrix G is given by 12 and 0, because here you don't have anything, so here is 0. Okay, so it is proven that this equation is same with this equation. Okay, so next, when we have the equation, we need to find the general solution for I1t and I2t. So we are going to use the method of undetermined coefficient to find I1t and I2t. Okay, so for part 1, first of all, need to find the complementary function IC for the homogeneous system. Okay, so from the equation just now, we need to write in the matrix form. Okay, so the matrix form I prime is equal to A plus matrix I plus G. Okay, so this is from the previous slide. Okay, and then after that, based on this, you need to find the eigenvalue and the corresponding eigenvector. Okay, so macam biasa, based on matrix ni, elemen A11 dan elemen A22 kita kena minuskan dengan lambda. Okay, so ini here kita minus dengan lambda, here also kita minus dengan lambda. Elemen ini dan ini kita remainkan dia 4 and 2. And then after that, once you dah dapat matrix ni, kita kena cari determinant value, and then it is said that the determinant value should be equal to 0. Okay, so and then from there kita boleh cari apa nilai lambda kita. Okay, so you just kembangkan persamaan. So negatif 6 minus lambda multiply dengan negatif 4 minus lambda minus 2 multiply with 4. Okay, and then after that you just kembangkan you punya persamaan. You akan dapat lambda squared plus 10 lambda plus 16 equal to 0. So you try to solve your quadratic equation by using calculator. You akan dapat lambda equal to negative 2 and lambda equal to negative 8. Alright, so based on this, you know that your eigenvalue is real and different. Okay, so once you dah dapat eigenvalue, kita boleh cari eigenvector. So, macam biasa, for the first eigenvalue, which is negative 2, kita assume eigenvector kita adalah V1 equal to X1 and Y1. So, macam mana nak cari? Gunakan formula AV multiply dengan lambda V. So, you just substitute value of matrix A, value of eigenvector V and lambda. Lambda is negative 2. And then once you just substitute, kita kembangkan persamaan row by row. So, for the first row, negative 6X1 plus 4y1 equal to negative 2x1. Okay, so and then after that, you just rearrange your equation. You akan dapat y1 is equal to x1. Same goes to the second row. You akan repeat the same process. You akan dapat juga y1 is equal to x1. Okay, so once you dah dapat persamaan ni, kita katakan x1 adalah 1. So, bila x1 1, y1 juga adalah 1. So, that's why eigenvector v1 is equal to 1 and 1. Okay, so once you dah dapat eigenvector untuk lambda 1, kita proceed untuk lambda 2. Okay, untuk lambda 2, dia punya eigenvalue is a negative 8. Then, we repeat the same process. Okay, so kita masukkan AV equal to lambda V. And then kita kembangkan row by row. So, from there, you dapat tahu yang y2 is equal to negative x2 over 2. Okay, so same goes to the second row. You akan dapat sama juga, y2 is equal to negative x2 over 2. So, based on the equation, let x2 is equal to 1. So, 1x2 is equal to 1, y2 is equal to negative 1 over 2. So, 1 over 2 is equal to negative 0.5. So, the eigenvector of v2 is given by 1 and negative 0.5. Okay. So, once you dah dapat eigenvector, kita kena check whether the eigenvector is a linearly independent or not. So, how to check? You need to calculate the determinant value. So, untuk masukkan balik nilai v1, V21, V12 and V22, and then calculate the determinant value. So 1 multiply dengan negative 0.5, you dapat negative 0.5 minus 1. Okay, so you calculate, you akan dapat negative 1.5. So it is not equal to 0. So bila dia tak equal to 0, kita consider it is a linearly independent. So and once kita dah tahu dia linearly independent, kita boleh terus proceed kepada step number 4. So kita kena write the solution. Okay. So formula ni you jangan risau, kita bagi dalam appendix untuk during your final exam nanti. Okay. So kita boleh write the solution for the complementary function IC is equal to C1 multiply dengan V1. V1 is 1 and 1, exponent negative 2t. So, 2 is your lambda 1, plus C2, V2 is 1 and negative 0.5, exponent negative 8t, because your lambda 2 is negative 8t. Okay, so this is your complementary function. So, once you have your complementary function, next, we go to the part number 2. We need to find the particular integral for the non-homogeneous system. Okay, so, how to assume IP? IP is assumed based on G. So, your G is given by 12 and 0. So, this is a polynomial function. So, we can assume IP is equal to U1 and U2. And then, once you assume your IP, you need to check. You need to compare whether your IP is equal to IC or not. So, in this case, your IP is not equal to IC. So, this is your IP. So, you just obtain your IP prime. So, your IP prime is given by 0 and 0 because here you differentiate U1 over T, you got 0. So, here 0. U2 differentiate over T, also you got 0. Okay. So, next step, we need to compare IP prime with I prime. Okay. So, from the question, the equation is given, the matrix is given by this. Okay. So, ini you dah dapat awal-awal. And then from step 2 above, you tahu juga IP prime is equal to 0 and 0. So, you need to substitute here into here. So, you akan dapat 0, 0. Okay, so you salin balik ni into here. Okay. And then, this matrix I, you need to substitute with value of IP. So, tadi you tahu IP sama juga dengan U1 and U2. Okay, so you ganti dekat sini. So, once you dah ganti everything, kita kembangkan persamaan dia row by row. Okay. So, untuk yang row yang pertama, negative 6U1 plus 4U2. So, dekat sini you ada 2U1 minus 4U2. Okay. So, bila kita dah kembangkan, kita boleh selesaikan. Untuk first row, 0 is equal to negative 6U1 plus 4U2 plus 12. Okay. So, we try to rearrange it so that you have U2 is equal to 6U1 minus 12 over 4. Okay, and then we go to the second row. 0 is equal to 2U1 minus 4U2 plus 0. Okay, and then for, after that, you just need to substitute the value of U2 with this equation. So, you ganti U2 dekat sini. And then, 4 dan 4 boleh cancel. So, you akan dapat 2U1 minus 6U1 plus 12. And then, selesaikan U1. You selesaikan, you dah akan dapat U1 sama juga dengan 3. Once you dah dapat nilai U1, ganti balik ke dalam persamaan ini. So, you akan dapat U2 equal to 1.5. So, finally, IP is given by 3 and 1.5. So, once you dah dapat IC dan you dah dapat IP, kita boleh obtain general solution for the system order LDE whereby I is equal to IC plus IP. So, you tulis balik, you punya I is equal to, so this is your IC and this is your IP. Okey, atau you boleh juga tulis dalam bentuk persamaan. I1T sama juga dengan C1 eksponen negatif 2T plus C2 eksponen negatif 8T plus 3. And I2T is equal to C1 eksponen negatif 2T minus 0.5 C2 eksponen negatif 8T plus 1.5. Okay. So, ini adalah general solution for I1T and I2T for the circuit given. Okay. So, that's all. Thank you for watching.